Hello guys, how are you today? So today I'll be explaining the physics AMS of term 1 week 6. It's AS physics, okay? Now, this quiz has a lot of solving and a lot of equations. Just to start it up before we start the quiz, what you need to do in the exam is write all of your given and remember the equations and how to use the equations. Once you have all of your given, you can then know, okay, I will use this equation because I have these given and all of this. So this is how we are supposed to solve this quiz mainly. So I'm gonna start with the very first question. It's very easy. Two light sources of the same frequency, when they have the same frequency means they have the same wavelength as well, and a constant phase difference are said to be what? They are said to be coherent. How do we spell coherent? C-O-H-E-R-E-N-T sources. So two light sources of the same frequency or the same wavelength and a constant phase difference are said to be what? Are said to be coherent. I don't think we need the caps. Coherent sources. By the way, this quiz, in the answer key, some of the questions are wrong. Some of the answers are wrong, so please do not focus on these. I asked my teacher and I got all of the answers, so do not focus on the answers that are in the end. I'm gonna solve and I'm gonna put the correct answers based on the solving. So two sound sources emit sounds of wavelength lambda and amplitude A. Okay, so we have wavelength lambda and amplitude A. What does a wavelength mean and what does an amplitude mean? We have this wave over here. From here to here, this is considered what? This is considered a wavelength lambda. And from here to here, this is considered what? This is considered the amplitudes, okay? So this is the difference between wavelength and altitude. So they said that two sound sources, okay, will meet at some point. So we have this wave will meet with this wave over here, okay? And they told us what? They told us that both of the sound sources have what? They have the same wavelength, right? And they both have what? They both have the same amplitude. So what did they tell us? They told us when these two waves met, what happened? They created one big wave that has an amplitude of what? It has an amplitude of 2 alpha. But what will happen to the wavelength? The wavelength will stay the same. It will stay as lambda. It does not change. Okay, so when these two waves met together, they created a giant wave, which is having an amplitude of 2a, okay? So what can we say about this? We can say about this that it is constructive interference. Now, when we are defining interference, we're not ever gonna say that they will meet or they will coincide. We use a very important term, which is what? Which is overlap. So if they asked us to define interference, it is when two or more, or let's just say two, when two waves overlap with each other, okay? So in this scenario, the red wave and the blue wave overlap together and they form this big wave, okay? And we said it's constructive because it's building up the wave. It's not breaking it down. It became bigger. So what is the equation for constructive interference? So constructive interference. What is the equation for it? Knowing that they want us to find what? They want us to find possible path differences. What's the equation of the path difference in a constructive? It is what? It is delta L, which is path difference, is equal to what? Is equal to m lambda. If they told us destructive, or if we found out that it's destructive, delta L would be equal to what? To m plus 1 over 2. Please do not forget the brackets, lambda. Okay, but us, we're gonna focus on the constructive interference. They want us to find possible path differences. Delta L is equal to m lambda, where m is a multiple, meaning a whole number, meaning 0, 1, 2, 3, 4, 5, a multiple of lambda. So definitely we're not gonna take any decimals, okay? And we're not gonna take a. Why? Because a is not given to us as a value. A could be a decimal point, it could be a whole number. We do not know. If we do not know what's the value, we're definitely not gonna choose it. So we are left with two options, which is 10 lambda and 5 lambda. And as you can see, they are both whole numbers, meaning that they are both what? They are both multiples of lambda. We'll now move on to question number 3. What does it say? It says, consider an ocean wave traveling normally towards two gaps between two islands. The diagram below is not to scale. The change in direction of propagation of the waves is due to the diffraction phenomena. Now, the pattern formed by overlapping waves, when you see the term overlapping, the first thing you think of is interference. This is the interference phenomenon. Now they told us, assume the amplitude of water wave is 25 centimeters. Perfect. So they want the displacement of the water wave relative to the position at point X. Now, at point X, what do we see? If you notice, the darker blue lines, they are what? They are the crests. And the gaps in between, this is what? Is the troughs. It looks like a Wi-Fi. So the darker blue line is the crest, and the gap in between is what? Is the troughs. And we are assuming that they are all of what? They are all of the same amplitude. So let us say we're dealing with X. In X, we have what? We have the meeting of a crest and a crest, both of amplitude 25 centimeters. So if a crest and a crest meet, and they both have an amplitude of 25 centimeters, they're going to form a bigger crest, which is what? Which will have an amplitude of 50 centimeters. Whereas if we were asked for Y over here, as you can see in Y, it's the intersection of what? It's in the intersection of a crest and a trough. So what can we say from this? It's a crest and a trough, both of amplitude 25 centimeters. But because they're going in opposite direction, they are destructive. So then they will give us what? 25 minus 25, which is what? Which is 0 centimeter. So no wave will form. So this is 50 centimeters and this is 0 centimeters. Let's move on to question number 4. Let us wait for it to load. Here we go. In a young double-slit experiment, the following pattern of light and dark fringes is obtained. The distance between two, I think here they mean 4, by the way, it's not 2, it's 4. The distance between 4 bright fringes, because as you can see, 1, 2, 3, 4 bright or white fringes is indicated below to be what? To be 5.4 millimeters. So what does this represent for us? This represents for us that it is the distance X, or let's call it Y. The distance Y, okay, from the first bright fringe to the last bright fringe, which is the 4th one. Now what are they telling us? They told us that the light in the experiment has a wavelength of 600 nanometers and the distance to the screen is 1.2 meters. They want the spacing between consecutive bright fringes to 1 decimal place. How do we find that? Very simply, we will take the total distance between the 4 fringes, which is 5.4 millimeters. Of course, you need to change, actually in this scenario, we don't need to change anything. So 5.4 millimeters divided by what? Divided by the number of dark fringes in between. So we have 4 bright fringes, right? But how many dark fringes do we have in between? We have 3 dark fringes. So it's gonna be the total distance, which is 5.4 millimeters, divided by the number of darks in between. So it's gonna be 5.4 divided by 3, which will give us an answer of what? Of 1.8 millimeters. Now, in question part B, the separation of the slits to 1 decimal place. How do we find the separation? First of all, what is the definition of separation? The definition of separation is the small d. So we need to find the small d. Let us go and find all of our given. First of all, we know that the y of 1 is going to be what? Is going to be 1.8 millimeter. But how do we change from millimeter to meter? We will multiply by 10 to the minus 3. So times 10 to the minus 3 meters. This is our y. Perfect. What do we also have given? We have the wavelength lambda. Lambda is equal to 600 times 10 to the minus 9 meter. I'm going to leave the conversion to you guys. This is lambda, by the way. We also have m. M is 1 because we said that between 2 consecutive bright fringes, meaning that m is going to be 1. Perfect. And then what do we also have? We also have the D is gonna be what? It's gonna be 1.2 meters. So using all of these four given, how will we be able to find the small d? Very simply, we need to remember the equation, which is y is equal to m lambda capital D over small d. Okay, where capital D is what? Capital D is the distance between the slit and the screen. Small d is what? Is the gap or the separation. Okay, lambda is the wavelength, y is the spacing between consecutive fringes, and then m is what? M is the number. Okay, so now in order for us to find d, what do we need to do? We can change the equation, or we can substitute it directly, whichever way you please. I prefer to change the equation. So d is gonna be equal to what? To m lambda d over y. Perfect. So how do we find the value of d? It's gonna be m, which is 1, times lambda, which is 600 times 10 to the power of minus 9, times d, which is 1.2, over what? Over y, which is what? Which is what is y again? 1.8 times 10 to the power of minus 3, and we will get an answer which is what? Which is 4 times 10 to the minus 4 meters. So we'll change it into millimeters. It will be 0.4 millimeter. I'm gonna leave the conversion for you guys. So we have the value over here, which is what? Which is 0.4 millimeter. Now, a very, very important part C. What does it say in part C? They want us to find the path difference, and path difference is what? Is delta L between light rays that form the dark fringe. When we say dark fringe, this means what? This means destructive interference. Perfect. So it's gonna be delta L is equal to m plus half, don't forget the brackets, multiplied by what? Multiplied by lambda. So delta L is gonna be what? It said between, sorry, my bad, that forms the dark fringe X. Dark fringe X is in which position? It's the first dark directly after the central brightness. So that means M is equal to 0. So the first dark after central brightness, M is equal to 0. The first bright after central brightness, M is equal to 1. So delta L is 0 plus half lambda. What does that mean? That means delta L is half of lambda, which is what? Which is 300 nanometers. Perfect. We'll move on now to question number 5. What does it say? It says that the slit separation, sorry, let's read it from the beginning. A monochromatic light source, meaning one color. Okay, one color means one wavelength. One wavelength of 520 nanometer, which is 520 times 10 to the minus 9 meters, is directed at a diffraction grating of 1 centimeter, and that has what? 500 slits. They want us to find what? They want us to find the slit separation. When we say slit separation, that means they are looking for D. Now, in this scenario, how do we find D? There's a new equation we need to know, which is what? Which is small d is equal to 1 over the number of slits, okay? Of course, we need to change it based on what we have. So it's, in my opinion, it's always preferable for the top to be what? To be 1 meter, okay? So, or like not necessarily 1 meter, just for the top to be in meters. So we start, D is equal to 1, which is the diffraction grating length, 1 centimeter. How do you change it into meters? You need to multiply by 10 to the power of minus 2. Okay, now it will become in meters. Over what? Over the number of slits, which is 500. So if you put it on the calculator, it's going to be 1 times 10 to the power of minus 2 over 500, which is what? Which is 2 times 10 to the power of minus 5 meters. But notice they want it in micrometers, so we will change it to micrometers by multiplying by 10 to the power of 6, and we will get an answer of 20 micrometers. Perfect. Now, the angle with the horizontal at which the 6th bright fringe is observed. So what do we have now? We have the wavelength lambda, which is 520 times 10 to the power of minus 9 meters. Then we have what? We have the small d, which is 20 micrometers, which is 20 times 10 to the minus 6 meters. Then we have m, which is 1, and we need to find what? We need to find the angle theta. So what's the equation that correlates the small d, the lambda wavelength, and the m? It's very simply d sine theta of course, I forgot to mention the angle as well. D sine theta is equal to what? Is equal to m lambda. So very simply, D, which is 20 times 10 to the minus 6, times sine theta is equal to m, which is 1 times lambda, which is 520 times 10 to the power of minus 9. So we'll move this to the other side. Theta is equal to 520 times 10 to the power of minus 9 over 20 times 10 to the minus 6. And we will get, oh, my bad. I forgot that m is 6. You see, guys, one small mistake can change the whole equation. So don't forget to multiply by 6. That's my mistake, my bad. Good thing I did the mistake so you guys can see how if you do a mistake in the exam to pay attention to it. So it's going to be 520 times 10 to the power of minus 9 times 6, okay, because m is 6, over what? Over 20 times 10 to the power of minus 6. We will get our answer. We will do shift sine answer. So sine inverse of all of this. Shift sine answer. And we will get an angle which is approximately what? Which is approximately to one decimal place, it is 9.0 degrees. So 9.0 degrees. Now, which of the following statements are true? First of all, the light changes direction of propagation due to interference? No. The dark fringes observed are due to the diffraction of light? No. All light passing through gratings is coherent? This is true. Then, the bright fringes that, why first of all? Because it's a monochromatic light source, meaning it's one wavelength, and because of this we will say that it's coherent. The bright fringes that are observed on the screen are due to the interference of light. This is also true. And then the light passing through diffraction, grating slows down. No, it does not. Now we'll move on to question number 6. Let's hope that the question loads at least. Let's give it a couple of minutes. Okay, perfect. Question number 6. To investigate the properties of light, a group of students conducts a double-slit interference experiment in a laboratory. The slits are separated by this distance. Of course, please write down all of your given and change it to meters. In my opinion, you need to change everything to meters. So 0.04 times 10 to the minus 3 meters. This is the separation distance, which is small d. Then the screen is placed away 0.6 meters, so capital D is 0.6 meters. Then a monochromatic light source, meaning it has one wavelength, and a coherent light source, meaning that two light sources that have the same wavelength and the same frequency and the same path difference, or sorry, my bad, the same phase difference, okay? They are used to produce an interference pattern on the screen. They told us what the fifth order bright fringe, meaning that m is equal to 5, is observed at a distance of 4.8 centimeters. That means y is equal to 4.8 times 10 to the minus 2 watt meters from the central maximum, the central brightness, okay? Perfect. So now we have all of our given. Please write down all of the given. I'll give you like 5 seconds to write down all of the given. And now, after you write down all of the given, I'm gonna go now and I'm gonna answer the questions. The angle between the fifth bright fringe. Fifth bright fringe means that m is equal to 5. And the central axis, there's an equation we need to memorize, which is that tan theta is equal to what? Is equal to the distance y, the position y over the capital distance d. How did we get this? Very simply, they said, oh, we have a light source coming like this to the fifth bright fringe, right? And let's say this is our central brightness over here. So as you can see, it's a triangle, right? And what is this over here? This is the distance y, okay? And this over here is the distance d. And they want which angle? They want this angle over here. So how can you deal with this angle? Very simply, to find angle theta, you will do tangent theta is equal to what? Is equal to the opposite over the adjacent, very simply. So tangent theta is equal to y over d. So y, we got it previously. If you wrote it down, your life's gonna be much easier, trust me. It's gonna be 4.8 times 10 to the power of minus 2 over capital D, which is what? Which is 0.6. Of course, we need to put it on the calculator. Tangent theta is equal to this, right? So 4.8 times 10 to the power of minus 2 over 0.6, we will get this answer. And now we need to do shift tangent answer, and we will get an answer which is approximately 4.6 degrees. So theta is approximately, what is approximately 4.6 degrees. We'll now move on to part B. The wavelength of the light used in the experiment to 1 decimal place. They want us to find the wavelength of the light used in this experiment. So what do we have? We have in our given M, we have to find lambda, but we have small d, and we also have the value of theta. We found it above. So using these four, let us find the value, okay? So what's the equation? Of course, we also need lambda. So what's the equation? It's that d sine theta is equal to m lambda. Perfect. So let's substitute d, which is what? What's d? D in this scenario is 0.04 times 10 to the power of minus 3 meters times sine 4.6, all of it over what? All of it over 5, which is what? Or sorry, no. All of it is equal to what? Is equal to 5 times lambda. So you will move 5 to the other side. That's why it becomes over 5, right? So what's it gonna be now? It's gonna be 0.04 times 10 to the power of minus 3 times sine 4.6 over what? Over 5, and we will get the answer, which is approximately 6.41 6 times 10 to the power of minus 7 meters, but they wanted in nanometers, so I will leave you guys to change it from meters to nanometers. It will be 641.6 nanometers. Perfect. So 641.6 nanometers. We'll move on now to question number 7. Let's hope the quiz is not like the chemistry yesterday where it took like a trillion years to load. Let us see. Perfect, finally it loaded. Two identical loudspeakers P and Q are placed 2 meters apart and emit sound waves and a phase at a frequency of very, very important to keep in mind that frequency, we may need it. A microphone is positioned 2.5 meters from speaker P and 2 meters from speaker Q. If the speed of sound, what is this? This is the speed V. What type of interference does the microphone detect? Perfect. They want us to find the interference. Now what do we have? We have sound, we have frequency, we have L1 and L2. So using these, what can we find? We can find delta L. First of all, delta L is L1 minus L2 or L2 minus L1, whichever way, it doesn't matter. I think it's preferable to do L2 minus L1 in this scenario, always bigger minus smaller. And what equation do we know that also consists of delta L? Delta L is equal to m lambda, or delta L is equal to m plus half lambda. And we can only determine after finding what? After finding lambda. Okay, perfect. How do we find lambda? Very simply, first of all, we know that lambda is equal to the speed over the frequency. So in this scenario, it's going to be the speed, which is 340, over the frequency, which is 680, and that's going to be what? That's going to be 0.5, I believe, meters. So now we have the value of our wavelength. Perfect. Now, can we find the value of delta L? Yes, we can find the value of delta L by doing 2.5 minus 2. Remember, delta L is always positive, so it's going to be 0.5 as well. So now it's going to be 0.5 is equal to m, which can be either a multiple of lambda or a multiple of half lambda, okay? M times what? Times 0.5. Perfect. Now we will move this to the other side and we will get what? We will get 0.5 over 0.5 is equal to m. So m is then equal to 1. Because m is what? M is equal to 1. In this scenario, then we say that it is constructive interference. What if, just imagine this scenario, what if we solved and we used this equation and we got m to be what? M to be 2.5. Let's say we got m to be 2.5. Because it's not a whole number, because it's a decimal, the 0.5 proves that it's what? It's half coming in. It's like m plus half, okay? Then this means it's what? It's destructive interference. But in our scenario, we got it to be a whole number. It's not plus half. So what does this mean? This means that it is a constructive interference. We'll move on now to question number 8. What does it say in question number 8? I think I should get like a stopwatch to see how long it like takes for the question to load. Let us see. Okay, perfect. Question number 8. Please pay attention to question number 8. They don't put the answers. I don't know why. The first one is true, the second one is wrong as well. Okay? So, let us see what we have. We have a monochromatic light, meaning that it has the same wavelength, with a wavelength of 520 nanometers, so 520 times 10 to the power of minus 9 meters, is directed at a diffraction grating. Okay, now the slits of the grating are what? Are spaced this much meters apart. So we already have it in meters. It's 3.33 times 10 to the minus 6 meters. Perfect. What are they asking us? They're asking us the first order and fourth order maxima are observed on the same side of the central maximum. What is the angular separation between these two spectral lines? What does this mean? This means we need to find the theta at 4 and we need to subtract it from the theta at 1 to get what our value, which we're going to call it delta theta. So let us find the theta at 4. What's the equation? We have the wavelength. We have small d. What do we need as well? We also have m. So we only need to find theta. So perfect. We can do it. So theta, if the equation is d sine theta is equal to m lambda, and we need only theta, that means it's going to be m lambda over d. And then theta is going to be what? It's going to be equal to sine inverse of m lambda over d. So very simply, let me just put the equation on top. Theta is equal to sine inverse m lambda over d. Since we have this equation, we can just substitute the values of 4. So the first theta is sine inverse m, which is 4, times lambda, which is 520 times 10 to the power of minus 9, over small d, which is 3.33 times 10 to the power of minus 6, minus what? Minus sine inverse of 1 times 520 times 10 to the power of minus 9, okay, divided by 3.33 times 10 to the power of minus 6. Let's put it on the calculator. Shift sine 4 times 520 times 10 to the power of minus 9 over 3.33 times 10 to the power of minus 6 minus sine inverse of what? Of 1 times 520 times 10 to the power of minus 9 over 3.33 times 10 to the power of minus 6. So we're gonna get an approximate answer of what? Of 30 degrees. So 30 degrees is the answer over here. Which diffraction order will not appear in the pattern? Very simply, when they say will not appear, that means we need to find the maximum. And to find the maximum, this means that theta is equal to 90 degrees or sine theta is equal to 1. Perfect. What does this mean? This means very simply, when we put it in the equation, d sine theta equals m lambda, sine theta will be substituted by 1. That means d is equal to m lambda. D in this scenario is what? Is 3.33 times 10 to the power of minus 6 is equal to m, which we need to find, times lambda, which is 520 times 10 to the power of minus 9. Now what do? We put it on the calculator. So 3.33 times 10 to the power of minus 6 over 520 times 10 to the power of minus 9. And we will get an approximate answer of 6.4. So m is approximately 6.4. Now, 6.4 is the maximum, meaning, of course, you cannot have a diffraction order of 6.4. It's either 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As long as it's a whole number, it should not have decimals. That means the maximum it can go is what? Is 6. But the one that will not appear is the one after, which is what? Which is 7. And ironically, it's like the infamous joke going around now, which is 6, 7. That means the 7th diffraction order does not exist, and then the 6th one does exist, however. Now this one, they don't have an option of 7th. I believe this is a mistake. So please do double check with your teachers. I'm just going to put whatever answer for now. We'll move on to question number 9. What does it say in question number 9? It says, laser light of 650 nanometers, so 650 times 10 to the minus 9 meters is incident on a diffraction grating. The second order, meaning that m is equal to 1, at an angle of what? Of 32.5 degrees. That means theta is 32.5 degrees. with respect to what? With respect to the central maxima. What do they want us to find? They want us to find the distance separating two neighboring slits. That means they want D, okay? So how do we find D? If we have lambda, if we have theta, and if we have m, we'll use the equation D sine theta equals m lambda. So we need to find D. That means D is m lambda over sine theta. So it's gonna be m, what's m? 1 times theta, sorry, times lambda, which is 650 times 10 to the power of minus 9, over what? Over sine theta, so sine 32.5, and we are supposed to get an answer, which is what? Which is approximately, oops, my bad, you see I did another mistake. Good thing I noticed before I put it on the calculator. M is 2. Please, please, please pay attention. And I don't know why I'm not focusing today. Second order means that M is 2. It does not mean M is 1. My bad, my mistake. Second order means that M is 2. By the way, it's a good thing I'm doing these mistakes in the video so you guys can see. So you will not make the mistakes in the exam, okay? So if you put it on the calculator, 2 times 650 times 10 to the power of minus 9 over sine 32.5, you will get D to be approximately 2.42 times 10 to the power of minus 6, okay? So this is 2.42. It's not even an option, by the way, but the answer here is 2.42. I don't know, the whole quiz is wrong. It's 2.42 times 10 to the power of minus 6. I'm just gonna put choose because it's an answer. That's very funny. Okay, we'll move on now to part B. The number of slits per centimeter is. So how do we find the number of slits? Remember the equation, D is equal to 1 over the number of slits, and 1 always is in meters. So that means the number of slits is 1 always in meters over what? Over D. So it's gonna be 1 over what? Over what we got before, which is 2.42 times 10 to the power of minus 6. So, okay, but however, before we proceed, we want the number of slits per centimeter. So, yani, we may need to change this from 1 meter into centimeter. How do we change it? We change it by multiplying by 10 to the power of minus 2. So it's gonna be 1 times 10 to the power of minus 2 divided by what? Divided by 2.42 times 10 to the power of minus 6. So we will get an answer of what? We will get an answer of 4,132 almost slits per centimeter. Now I don't know if this is an answer. You see, it's not even an answer as well. I'm just gonna put choose. So by the way, this is like the quiz that has some wrong answers. So this is how you solve it, and this is how you're supposed to get it. So it's supposed to be 4,132 slits per centimeter. Now, let's move on to question number 10. Hopefully it will not take another decade to load. Perfect, it did not. Amazing. A physics student set up a double-slit experiment in the lab. The slits are distanced by what? By 30 micrometers. That means 30 times 10 to the minus 6. And this is what? This is small d. And the laser beam is used to illuminate them. The fourth order, I will not make the mistake this time. It's 4, okay? Bright fringe, pay attention. Bright fringe is observed at an angle of what? Theta, being 6.2 degrees. So they want the wavelength. How do we find the wavelength? If we have theta, m, and d, we use the equation. D sine theta equals m lambda. So 30 times 10 to the power of minus 6 times sine 6.2 is equal to 4 lambda. So move 4 to the other side. Lambda is equal to this. Lambda is equal to 30 times 10 to the power of minus 6 times sine 6.2 over 4. And we will get it to be, change it of course into nanometers. I'll leave that to you guys. And that's going to be what? Approximately 810 nanometers. Perfect. Now we'll move on to part II. The maximum number of bright fringes that can be observed on both sides. I love this question. It's a very nice, very nice question. So, they want the maximum number of bright fringes. That means theta needs to be what? Theta needs to be 90 degrees. That can be observed on what? On both sides. We will see why I'm stressing on both sides now. So, D, we found D, which is what? Which is 30 times 10 to the minus 6, my bad. Times sine theta. Sine theta is 90. Theta is 90 in this case. Is equal to m, which we need to find, times lambda, which is 810 times 10 to the power of minus 9. So m will be equal to what? It will be equal to 30 times 10 to the power of minus 6 times sine 90 over what? 810 times 10 to the power of minus 9. So that's going to be approximately 37 fringes. But how is this? 37 fringes up. But as well, after the central brightness, we have 37 fringes. How? 37 fringes down. And we do not forget to include what? We do not forget to include the central brightness. So in total, we have 37 plus 37. How much is that? 74, in addition to the central brightness, which is what? Which is in total 75. This is for bright fringes. For dark fringes, you do not count the central brightness, okay? Part B. The experiment is now repeated using a light source with a shorter wavelength. So what's the equation? The equation is d sine theta is equal to m lambda, right? So we decrease the wavelength. If m is constant, okay, and d is constant, what will happen to the angle? If lambda decreases, then what's going to happen to the angle? It's going to decrease as well. Now let's say that we did not keep d constant. What's going to happen? D is going to decrease as well. So if d decreases, that means they are more closer together and they are compact. And actually, no, I think d stays the same, by the way. Never mind. D stays the same. But if we were like to change it, right, it would decrease as well. And it would be more compact and the fringes will become closer together. So if the experiment was repeated using a light source with a shorter wavelength, okay, they didn't change anything. So they did not change d and they did not change m, okay, right? So we just changed the wavelength. What will happen? The angle is gonna what? It's gonna decrease. Perfect. So the maxima and the minima, if the angle decreases, of course, they're gonna become closer together, okay? So they will become more compact and there will be a greater number of total fringes. Oh, so actually they did not keep m constant. They said, okay, if I decrease lambda, what's gonna happen to m? It's gonna increase. Why? Because they are on the same side of the equation. That means they're inversely proportional to each other. So as lambda decreases, m is gonna increase. So decreases, move closer together, compact, and we'll have a greater total number of fringes on the screen. We'll now move on to question number 11. Very simply, consider an ocean wave traveling normally towards a gap on two islands. Spreading out of the waves is called diffraction. Then why do the waves spread so little? Very simply, look at the gap. The gap, which is, take with your finger, very big, is very, very huge compared to the wavelength. So because the gap is greater than the wavelength of the wave, there's gonna be little spread. Okay, perfect. Let's move on to question number 12. Hopefully it's not gonna take a long time to load as well. Really, really long time to load. Perfect, it loaded. Let's move on. Consider an ocean wave traveling normally towards a gap between two islands. The speed of the wave is what? Is 2.5 meters per second. This is v, and the period is 5 seconds. We know that the period is equal to 1 over the frequency. Period is capital T, okay? That means if we want to find the frequency would be 1 over the period. So it will be 1 over 5, which is what? Which is 0.2 hertz. So now what do we need to find? We need to find the wavelength of the wave. We know that the wavelength is the speed, which is 2.5, over the frequency, which is 5. No, sorry, that's the period, which is 0.2. So 2.5 over 0.2, this will give us an answer of what? This will give us an answer of 12.5 meters. We move on to part B. What does it say? Which of the following is the possible size of the gap between the islands? Let's see the possible options. We have 100 meter, 0.5 meter. Okay, definitely, look, 100 meter, 250 meter are wrong. Okay, why? Because if the gap is wider than the wavelength, there's gonna be very little diffraction. Perfect. Now 2 and 0.5 are wrong, because if they are smaller than the wavelength, it's gonna be extreme diffraction, which is not the case. Or like the wavelength, or like, sorry, the wave will not even pass. Maybe it might not even pass because it's so small. Okay, but 15 is the right size because it's closest to our wavelength, and the most diffraction happens when the width of the gap is closest to our wavelength. Perfect. Now let's wait another trillion years for question number 13. I think 13 is very easy. It's not that solving. Perfect, perfect, it loaded. A Young's double-slit experiment is conducted in a school lab using visible light lasers. Okay, so wavelength is usually in what? In hundreds of nanometers. Distance to the screen is usually in hundreds of centimeters, or which is meters basically. Slit separation, small d, is usually in micrometers, so hundreds of micrometers. Fringe separation is usually how? It's usually few millimeters. Perfect. Now, question number 14, perfect, it loaded. The graph below shows the sine of the angle of the second, that means what? M equal to 2, diffraction maxima of light for different wavelengths. What are they asking? They want the slope of the graph. Because it's a straight line passing through the origin, we can do rise over run. You can choose any point. For example, I choose this point over here with this point over here. So, yani, it is, I think I went a bit off. Here we go. So I'm gonna take this as 600 and I'm gonna take this as 0.015. So it's gonna be the rise, which is 0.015, over the run, which is 600. So it's gonna give us 2.5 times 10 to the power of minus 5 what? Minus 5 nanometers. So of course we need to change it into meters because this is how they want it. How do you change it? Of course, my bad, it's minus 1. Why? Because here it's the value over the wavelength, so it's gonna be 2.5 times 10 to the power of minus 5 nanometers. So we need to change it into meters. Very simply, we change it into meters by multiplying by 10 to the power of 9. So it's gonna be what? It's gonna be 2.5 times 10 to the power of 4 over what? Over meter. So over here it's 2.5 times 10 to the power of 4. The slit separation in the diffraction grating to the nearest integer. So slit separation means they want d. And what's the equation to find d? Very simply, it's d equals, d times sine theta equals m lambda. So d, we need to find it, is equal to m, which they said above is 2, times lambda. Just choose any point. For example, this one and this one, 200 and 0.005. So it will be lambda, which is 200 times 10 to the minus 9, don't forget to change it, over what? Over sine theta, which is 0.005. So 2 times 200 times 10 to the power of minus 9 over 0.005. That's going to be 8 times 10 to the power of minus 5. Now you need to change it from meters into micrometers because this is how they want the value. So it's going to be what? Times 10 to the 6, so it's going to be 80 micrometers. Perfect. We move on now to question number 15. What does it say? It says, in a double-slit experiment, the following results are obtained. What did they tell us? They told us that the width of 10 fringes is 1.2 centimeters. That means the width of one fringe is how much? Is 1.2. Of course, change it into meters after. So 1.2 divided by 10. So it's 0.12 centimeters, which is what? Which is 1.2 times 10 to the 3, what? 10 to the minus 3 meters. Now this is what? This is our y. Our x is what? Our d. Our d is what? Separation of slits. Our d is 1.3 times 10 to the power of minus 3 meters. And then we have what? We have slit to screen distance, capital D. It's equal to what? It's equal to 2.8 meters. Perfect. They want us to find the wavelength lambda. So how do we find lambda if we have y, if we have small d, and if we have capital D? Very simply, it's y equals m lambda capital D over small d. M in this scenario, I believe it is 1 because they didn't state it, so we're just going to say that it's 1. Okay. Lambda, we need to find it. Capital D, we have it to be 2.8. Small d, we have it to be 1.3 times 10 to the power of minus 3. And then we have y to be what? To be 1.2 times 10 to the power of minus 3 meters. So now you do cross multiplication to find lambda. So lambda is equal to 1.3 times 10 to the power of minus 3 times 1.2 times 10 to the power of minus 3 divided by 2.8, which is what? Which is approximately, you need to change this into, I will of course leave the thing to change it for you, the changing of the units for you. So it's gonna be what? It's gonna be 557 nanometers. We move on to question number 16. I think they get easier after this. No, actually, yeah, they get easier after this. So laser light falls on a slit with 100 micrometers of what? Of width. That means this is what? This is the value of D, because this is the width of the slit. It's 100 times 10 to the power of minus 6 meters. A diffraction pattern from a screen that's 3 meters behind the slit. That means capital D is what? Is 3 meters. The distance behind the center of the central brightness figure and blah 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 is 13.5 millimeters, which is 13.5 times 10 to the power of minus 3 meters. They want the wavelength of the laser source, and we have what? We have first dark fringe, meaning M is equal to 1. We have Y, which is this much. We have capital D and we have small d, so we can find lambda by what? By Y is equal to M lambda big D over small d. Okay, so now you just need to substitute. So 13.5 times 10 to the minus 3 is equal to 1 times lambda times capital D, which is 3 over small d, which is 100 times 10 to the minus 6. Now you just solve it. Yeah, you just need to bring this up times 100 times 10 to the minus 6 divided by 1 times 3. You will get it to be, of course, you need to change it from meters to nanometers. You will get it to be 450 nanometers. Perfect. Now we move on. If the distance between the centers of the first and second minima to 1 decimal place, we know that between the central brightness and the first dark fringe, pay attention, first dark fringe is how much? Is 13.5 millimeters. And now they want us to find what? They want us to find the distance between the centers of the first and second minima. When they say first and second minima, they're asking for the actually they're asking for the difference of the first and second. So it's gonna be 2 minus 1, which is 1. That means M is equal to 1 again. So if M is equal to 1, then what's the value of the Y? What's the value of the distance? It's gonna be the same exact value, which is 13.5 millimeters. Now, very, 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 very important example. They told us that we know that the equation is Y equals M lambda big D over small d. They told us that if the same source is used, okay, and they decrease the distance between and they want to decrease the distance between the center of the central fringe and that of the dark fringe. That means they want to decrease Y by half. So you're multiplying this by half, or you are dividing it by 2. It's the same exact thing, okay? They want the size of the slit. So what is the relationship between the distance Y and the slit? They are inversely proportional. That means if you half Y, you're gonna double D, very simply. So if D was originally 100 micrometers, it's gonna be what? It's gonna be 200 micrometers. We now move on to question number 17. What does it say? It says the phenomenon that is associated with the spreading of waves as they pass through a gap around an edge is diffraction. Very, very easy. Perfect. We'll move on to question number 18. What does it say? The diffraction grating has 400 lines per millimeter, right? So this is what this is, N. The angle between the 0th and first order maxima for a certain laser is this much. So theta between 0 and 1 is 14 degrees. They want the wavelength. We also have M. M is what? Is 1 minus 0, which is 1. They want us to find the value of the wavelength. So what can we do? First of all, we know that d sine theta is equal to M lambda. Perfect. So we need to find d, and we have n. How do we find d if we have n? Very simply, it's going to be 1 over n. But remember that this is in millimeters. Of course, we need to change it into meters. So we're going to divide by 1,000, or you'll multiply by 10 to the power of minus 3, whichever works for you. I don't mind. And then n is 400. So it's going to be what? It's going to be 1 times 10 to the power of minus 3 divided by 400. So that's going to be 2.5 times 10 to the power of minus 6. Okay? This is d times sine theta, sine 14, is equal to 1 times lambda. So this will just go away. So 2.5 times 10 to the power of 6 times sine 14. How much is that going to be? That's going to be 6.04. Yeah. That means lambda is going to be 6.04 times 10 to the power of minus 7. So it's 605, approximately 605 nanometers. We'll move on to question number 19. What does it say? Water waves change their direction when passing through a gap. The extent to which ripples spread out depends on the relationship between the wavelength of the water waves and the width of the gap. As the width of the gap becomes blah 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 close to the wavelength of the water waves, the diffraction pattern becomes more noticeable. So the closer the width of the gap to the wavelength of the water waves, the more diffraction will occur. This is basically the whole point of the paragraph. Question number 20. In a double-slit experiment, the angle separating the line passing through the central fringe that passes through the second order bright fringe, that means central fringe m is 0, second order m is 2, so what is it gonna be? M is gonna be 2 minus 0, which is 2. Now, it has what? It has a theta of 1.33 degrees. The two slits are separated by a distance of how much? Of this much, which is 0.075 times 10 to the power of minus 3 meters. They want the wavelength. What do we have? We have m, we have d, and we have theta. So d equals sine theta times, d sine theta equals m lambda. So 0.075 times 10 to the power of minus 3 is equal, times sine 1.33 is equal to 2 times lambda. Perfect. So let us solve it. You just need to solve it. It's gonna be 0.075 times 10 to the power of minus 3 times sine 1.33 over what? Over 2. We will get an approximate answer of what? An approximate answer of 870 nanometers. Perfect. Now, we move on to part B. The angle formed between the central horizontal line through the median of the two slits and the line passing through the fourth dark fringe to 2 decimal places. Very simply. What do they want from us? They want the angle, theta, formed between the central horizontal line. Okay, so how much is that going to be? That's going to be, the central horizontal line passing through the median of the two slits. If it was second order and central fringe, so that's going to be 0. And that's going to be what? That's going to be 2. Okay, so what is their median? It's going to be 2 plus 0 divided by 2, which is 1. That means this is what m is equal to 1. And then here they told us that m is equal to 4. So what do I do? 4 minus 1, that's going to be 3. But pay attention, they told us that it's a dark fringe now. So how do you find it? You have the value of m, right? And you will just substitute it in, instead of it being m lambda, it will be m plus half times lambda. So in the equation, instead of it being d sine theta equals m lambda, it will now be what? It will now be d sine theta equals m plus half lambda, where in the scenario m is 3, my bad, lambda is 870 times 10 to the power of minus 9, and d is what? D is 0.075 times 10 to the power of minus 3. So that means sine theta is equal to what? Is equal to 3 plus half times 870 times 10 to the power of minus 9 divided by 0.075 times 10 to the power of minus 3. Okay. Let me just do times here. I forgot to put it. Now you need to do shift sign of answer to get the value of theta, and you will get theta to be what? You will get theta to be 2.32 degrees. Perfect. Now we'll move on to question number 21. What does it say? I think SDP is taking its time. It's like, you know what? Give me a break. I need to take a break. Because I feel like the video would be way shorter if, we were not waiting for SDP to load. Perfect. Here we go. They told us that the diagram below shows a monochromatic light, meaning that it has only one wavelength, one frequency. The light passes through the two slits and produces an interference pattern on the screen. Waves from slits S1 and slit S2 combine at point P at distance y from the central axis. The wavelength of the light is how much is... Oh wait, did they give us information above? No. But they gave us that the wavelength here, 545 times 10 to the power of minus 9 meters. Separation D is how much? Is 0.11 times 10 to the power of minus 3 meters. And the big distance D between the screen and the slit is 56 times 10 to the power of minus 2 meters. Assume that theta is the angle between point P and the central axis, and it is very small, okay? So what do they want? They told us that the position of y of the m equals 1 bright fringe at point P. So what do we have? We have lambda, we have small d, we have big D, and we have m, and they want us to find y. So very simply we use the equation y equals m lambda big D over small d. So y is equal to m times lambda times big D over small d. So how much is that gonna be? That's gonna be 1 times 545 times 10 to the power of minus 9 times 56 times 10 to the power of minus 2 over 0.11 times 10 to the power of minus 3. So we will get it to be approximately 2.88 times 10 to the power of minus 3 meters. So approximately, 2.77, not 88. So approximately in millimeters, because that's how they want it, it's gonna be 2.8 millimeters, because it's to 1 decimal place, 2.8 millimeters. Yalla, perfect. Question number 22. Hopefully it won't take long. Okay. A light ray passes through two slits separated by a distance of this much, meaning that d is equal to 0.03 times 10 to the power of minus 3 meters. And they told us that the screen is big D, 1.2 meters away from the double slit, and the second order, meaning that m is equal to 2. Bright fringe is 4.5 centimeters, meaning that y is 4.5 times 10 to the power of minus 2 meters away. Perfect. So what do they want us to find? The wavelength. Y equals m lambda big D over small d. So 4.5 times 10 to the power of minus 2 is equal to 2 times lambda, which is, where is lambda? Oh, we need to find lambda, my bad, times 1.2 over small d, which is 0.03 times 10 to the power of minus 3. So 4.5 times 10 to the power of minus 2 times 0.03 times 10 to the power of minus 3 over 2 times 1.2 will give us a value of lambda to be approximately 562.5 nanometer. Of course, this is after changing. Now, changing from meter to nanometer. Now, the distance between the adjacent bright fringes is, what do they mean, the adjacent bright fringes? This means that instead of it being second order, that means m needs to be equal to 1. So you just apply the same exact thing we've done. Y equals m lambda big D over small d, but m in this scenario is 1. So 1 times 562.5 times 10 to the power of minus 9 times 1.2 over 0.03 times 10 to the power of minus 3. And we will get our answer, which is in meter, 0.0225 meter. We need to change it to centimeter. So times 100, it will be 2.25 centimeter. Now we move on to question number 23. What does it say? Yalla, it's the last question. I want to finish. Come on. I want to post it. I'm so excited to post it. It's going to take another year. I'm just gonna pause the video and replay it when it comes. Finally, it loaded. A source emits what? 2 wavelengths, 430 nanometer and 510 nanometer. The source is used in a double slit experiment where the distance between two slits is this much. Of course, we need to change them all to meters. So lambda 1 is 430 times 10 to the power of minus 9 meter. Then lambda 2 is 510 times 10 to the power of minus 9 meter. Then distance d is 0.025 times 10 to the power of minus 3 meter. And then the distance capital D is 1.5 meters. So what do they want us to find? They want us to find the distance between the third and fourth, between the third order bright fringes to 1 decimal place. So what does this mean? This means that m is equal to 3. So they want us to find the distance of m being equal to 3 using lambda 1 and lambda 2. And then what do we do with it? We will subtract them. So what does this mean? This means y1, or let's say y2 minus y1. So it's going to be m, which is 3, times lambda 1, which is, let's take it as 510. 510 times 10 to the power of minus 9 times big D, which is 1.5, over small d, which is 0.025 times 10 to the power of minus 3, minus, again, m, which is 3 times the other lambda, 430 times 10 to the power of minus 9, times 1.5 over 0.025 times 10 to the power of minus 3. My throat is dry, sorry. So it's gonna be 3 times 510 times 1.5 over 0.025 times 10 to the power of minus 3, minus 3 times 430 times blah 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 times 1.5 over 0.025 times 10 to the power of minus 3. So we will get our lovely answer to be in meters. So it's 0.0144 meter. We need it to 1 decimal place in centimeters, so 1.4 centimeter. How lovely is that? 1.4 centimeters. Let's submit. Now it's gonna show that I have some wrong, but again, these wrong are from the quiz itself, unless I did a silly mistake. Hopefully I did not do a silly mistake. We need to wait another century for the answers to load. So hopefully I did not do any mistakes right now. But there's some answers from the quiz that are wrong initially. من أساسها it's wrong. So I'm just gonna wait for this to load. Oh, very funny. Look at you guys. The percentage. This is to waste a bit of our time, you know? I think my whole thing is glitching, by the way. I had to reload it in order for it to work. I think it's still loading. I think I did a mistake with spelling. I wrote interference. It's supposed to be with all E's. My bad. It's okay. It's just a silly mistake. Let's submit, and hopefully there are no wrong other than this one silly mistake of the spelling. Perfect. That's it. Thank you guys for watching. I hope you enjoyed and have a wonderful day.